Right, guys, we are in our second tutorial in physics, and this time we are dealing with problems once again. So this is test yourself activity 1. So in the first problem they say, let me just zoom in a little bit. Andile is jogging at a constant velocity of 2 meters per second along a straight road. He speeds up to a constant velocity of 3 meters per second while crossing at an intersection. Andile's mass is 50 kilograms. Now in number A they say calculate his change in momentum and show the direction. So what we are going to do, because they want the change in momentum, let's write down first the data. They said Andile is jogging at a constant velocity of 2 meters per second. So that would be the initial velocity, and that would be 2 meters per second along a straight road. He speeds up to a velocity of 3 meters per second, VF 3 meters per second, while crossing at an intersection, and the mass is 50 kilograms. So we will assume that Andile is moving in an easterly direction, and then they say calculate his change in momentum. And yes, so the change in momentum is equals to final momentum minus initial momentum. Remember, they are vector quantities, so this will be mvf minus mvi, which is mvf minus vi. The mass is 50 kilogram. What is the final velocity? That's 3 meters per second minus 2 meters per second, and we would just say 50 kilogram. 3 minus 2 is 1 meter per second, which is 50 kilogram meters per second. Now they want to know the direction. They said Andile is jogging at a constant velocity of 2 meters per second along a straight road. He speeds up to a constant velocity of that. So we can say this is 50 kilogram meters per second in the direction of motion, or in the original direction. So let's just say original direction, or in the direction of motion. We can state it in those two ways. Right, that was number A. Let's go to number B. Use a vector diagram to represent the change in momentum. So remember what that would require. It would require that we know the final momentum and the initial momentum. So final momentum is mvf, which is 50 kilograms multiplied by the final velocity of 3 meters per second. So 5 times 3, it's 15. Just write your 0. Kilogram meters per second, original direction. And then the initial momentum would be mvi, and this would be 50 kilograms multiplied by the initial velocity of 2 meters per second. 5 times 2, it's 10. Just write your 0. Kilogram meters per second, also in the original direction. Very good, because he was just speeding up as he was crossing the intersection. So now we want to demonstrate this. They said use a vector diagram to represent the change in momentum. So we know that the change in momentum is final momentum minus initial momentum, right? So how are we going to demonstrate this? So what I'm going to do, let me just draw up a line. what I'm going to do is to check what is the value of the change in momentum. So the change in momentum is this. Okay, this would be the change in momentum. That is fine. So I'm looking for the bigger value. The bigger value here is the final momentum. So I'm going to say change in momentum plus initial momentum should be equals to the final momentum. So this can be rewritten as that, because we have the final momentum as the bigger value in the values that we got here. Initial it's 100, final it's 150, the change is 50. So this is bigger. So this is what we're going to do. So this would be the final momentum. Now that is the bigger value. Let's now see the other one. Initial is bigger with 100. So I'm going to do this. This is the initial momentum, and this would be the change in momentum. So the sum of these two, initial and change, should give us final. So the sum, because they are heading in the same direction, should give us exactly that. This is very true. So we were able to answer number 1A and number 1B. Let's now go to number 2. A bowler bowls a 100 what is this? A bowler bowls a 100 cue cricket ball to a batsman. The ball approaches the bat with a constant velocity of 34. The bat strikes the ball and the ball undergoes a change in momentum of 5.4 kilometers per second in the opposite direction. Draw a vector diagram to show the initial momentum and the change in momentum of the ball. So let us try to look into this. Right, a bowler bowls a 100 cue cricket ball. So this is 100 grams. 100 gram, this would be the mass of the ball. So the mass is 100 gram. They've written this as Q. They should have said G there. To a batsman, the ball approaches the bat with a constant velocity of 34. So we have VI, which is 34 meters per second. Right. The ball strikes the bat strikes the ball and the ball undergoes a change in momentum. So we have the change in momentum, and this is 34 meters per second in the opposite direction. So opposite, so meaning the momentum is negative. Right. So okay, this is let me check. The ball approaches the bat with a constant velocity of 34. Okay, that is fine. Sorry, this is 5.4. Sorry, this is 5,4. The change in momentum is 5,4 kilogram meters per second in the opposite direction. I'm very sorry for that. Right, draw a vector diagram to show the initial momentum and the change in momentum of the ball. So we can calculate the change, the initial momentum, because the initial momentum is mass multiplied by the initial velocity. 100 gram, converting that to kilograms, that would be 0,1 kilograms multiplied by 34 meters per second. So let me just check that very quickly for you. So we can just say 0.1 multiplied by 34, and this would give us 3.4. So we have positive 3.4 kilogram meters per second. Which direction can we say this is heading? towards, we can say towards the Batman. Towards Batman. So this would be the direction, or we can say in the original direction of motion. So this would be the initial momentum, and we know that the change in momentum, it's negative. This is negative 5.4 kilogram meters per second in the opposite direction. Right, so we want to show the vector diagram of this. So I want you to see something here. I want us to see something here. We know that, okay, if this is true, we can find the final momentum, because look, the change in momentum is equals to final momentum minus the initial momentum. Do we have the change? Yes, there it is, negative 5.4 kilogram meters per second. Do we have the final momentum? No. Minus, do we have the initial? Yes, it is positive 3.4 kilogram meters per second. So this would be the initial momentum. Take this to the other side, negative 5.4 kilogram meters per second plus 3.4 kilogram meters per second equals final momentum. So the final momentum is going to be negative, because we're going to say negative 5.4 plus 3.4, and this should be minus 2. So we have minus 2 kilogram meters per second. So this would be final momentum would be negative 2 kilogram meters per second in the opposite direction. So that's exactly what we have. Final momentum is equals to negative 2 kilogram meters per second in the opposite direction. So let us try to draw this and see. Now I want you to see something here. Which one did we find as positive? Let's see this. We found only initial momentum as positive. Only the initial momentum is positive. The change is negative, and also the final is negative. And I want us to see this. Now let us check. The initial is positive. So we know that the change in momentum equals final momentum minus initial momentum. So only this is positive. So meaning I can take this to that side. I can have change in momentum plus initial momentum, that is equals to final momentum. I can have this if you take that value to that side. But I want to only be left with this one because it is positive. So initial momentum will be equals to final momentum minus the change in momentum. Something worthy of noting. This is very, very important. But let us try to check something here. Only the initial is positive. Final and change are both negative. So how can I make both final and change negative? How can I do that? So if this is what I have, I want you to look at this. Because this is positive, that is fine. So what I can do here is the following. Let me have this as negative. Now let's have this as negative. Let me just try to do this. Let me have this as negative so that you can see what I want to do here. So now check something. If this is negative, you're going to have this change in momentum, take this to that side, minus final momentum, and this will be equals to minus initial momentum. And I can draw it in this way. So I can do this, and this would be initial momentum, and it is in the opposite direction, right? And then I would have this change in momentum, and this change in momentum, where will it go? It will go in this direction. But I want you to check, we have negative 5.4, and what is the final momentum? Negative 2. And this negative, where is it? Yes, negative 2 is bigger than negative 5.4. So this would be smaller, which would be the change in momentum, and the final would be bigger. This would be the final momentum. So this minus that should give you this, and this is very true. Let's check. This minus this should give you that, and there it is. So this is in essence equals to the difference of those two, and then we are fine. Right, be that as it may, let's just go to number B. Let's go to number B. So that was number A. They said draw a vector diagram to show the initial momentum and the change in momentum of the ball. Fortunately, we showed the initial and the change, and we also showed the final, because we need to incorporate those three. They go as a 3 unit. Right, let's look at number B. Complete the vector diagram by drawing the final momentum of the ball in its correct direction without doing any calculations. Predict the magnitude of the final momentum. I think we have already done that. So meaning in number A, what you can do as a learner, just show the initial and the change. Just show the initial and the change. And let me show you something. Let's look at the magnitudes. The change, it's negative 5.4, and the initial is 3.4. So meaning, if we have to show only that, now look what is going to happen. So you are going to have your initial, and this would be your initial momentum, and you now have to show in the change, and the change is negative 5.4. So how are you going to show that? Obviously it will be in this direction, and this would be the change in momentum. So this would be the initial and the change. Very good. This is what they require only for A. And now for B, they say complete the vector diagram by drawing the final momentum of the ball in its correct direction without doing any calculations. Predict the magnitude of the final momentum. And this, the entire this would be for number B. This would be for number B. In fact, until here, just until here, this would be for number B. And they said complete the vector diagram, and then this would be to complete the vector diagram here. So here you are just completing the vector diagram, and let us see this, if this would work. So if you have this, do you see that this, if you try to incorporate the final, this is not going to work, because look what is happening. If you have the final, if you have the initial momentum and you have this change, therefore this would be the direction of the final. So this would be the final momentum. If you have to complete it, it would have to be in this way. because the difference of those two should provide you with that. So either you go this way or either you go that way. But I want you to see something. If this was going that way, this time it is going that way. And if this was going this way, it has to go that way. And if that was going this way, it has to go. So this is exactly one and the same thing. This is exactly the same. There's nothing wrong here, and there's also nothing wrong there. We have in essence drawn the same thing. This is the same thing using different approaches. This is exactly one and the same. So we have already answered number B. Number C, they say, calculate the final momentum by using an appropriate equation and compare your answer to the answer that is predicted to be 2 kilogram meters per second in the opposite direction of the ball. We have already done that. Final momentum is 2 kilogram meters per second in the opposite direction. But when you say that, this has to be positive. Please be careful. So when you say 2 kilogram meters per second in the opposite direction, that is your final momentum. The negative only shows us that it is in the opposite. But when you say 2 kilogram meters per second opposite direction, therefore you must write this as a positive. Very, very important. You must write this as a positive. Where is the direction? There it is. The momentum is positive in the opposite direction. And then you will be done. So that's all what I wanted us to share in this test yourself tutorial. And I think I will see you in the next chapter, where we will be dealing with Newton's second law expressed in terms of momentum.